Hello, we are here to learn about factoring, and the strategy that we are going to learn about is called difference of squares, which is sometimes shortened to be called DOS. Again, this is one of 3 different ways that we're going to learn how to factor. You should already know how to use GCF, or greatest common factor. Now we're going to learn difference of squares, and later you will learn sum product. The first thing that you need to know about difference of squares is that difference of squares should only be used after greatest common factor has already been considered. We learned greatest common factor first because it's a skill that's going to help us when we're doing difference of squares and sum products. So we should always think about that skill, greatest common factor, first. The second thing you need to know about difference of squares is that it is used to factor the difference of 2 perfect squares into 2 binomials. So, what we have here is we're going to have 2 things that are perfect squares. For instance, a squared and b squared. And it has to be the difference, which means subtraction. It has to be a subtraction sign in between 2 things that are perfect squares. Now, we're going to take these 2 things that are being subtracted, and we're going to create 2 binomials from that. And the binomials are going to be the square roots of what we have. So a and b. And then one's always going to be a plus sign and one is always going to be a minus sign. This last line is what all of our answers for difference of square problems are going to look like. Now, to really understand how we are going to do this, we have to know what perfect squares are. And what perfect squares are numbers that are created if a whole number is squared. So for instance, if we have the number 1, the perfect square of the number 1 is going to be 1 times 1, which makes 1. So the perfect square of the number 1 is 1. And then another perfect square would be, okay, what's 2 times 2? Well, 2 times 2 is 4, so 4 is a perfect square. Similarly, 3 times 3, which is 9, so 9 is a perfect square. Here's the rest of that table filled in for you. Now, let's actually put this into practice. The first thing that we need to notice is that I have a binomial, so I have 2 terms, and they're being subtracted. I cannot use difference of squares unless there's a subtraction symbol. Now, another thing that was said was that we should only do GCF if we've already we should only do difference of squares if we've already tried GCF. So I'm going to look at the numbers 81 and the number 64, and see if they have a greatest common factor. Well, they don't. They don't have any factors in common, so I can't do GCF. But I can do difference of squares. So what I need to do is get my parentheses ready and think about the square roots of these 2 numbers. So when I look at 81, well, 81 is 9 times 9. And then to make an x squared, I would need an x over here and one more x over here. Then, when I look at the 64, well, what times itself makes 64? Well, 8 times 8 makes 64. And then for difference of squares, there's always going to be 1 plus sign and 1 minus sign. And that is our answer using difference of squares. Number 2. First, we have to try GCF. So I'm looking at the numbers 3 and the number 75 and seeing if they both can be divided by the same thing. Well, they both can be divided by 3. So I put 3 in the front, and now I have to fill in my parentheses using everything else. So that would be n squared minus 25. Now, for this particular problem, I can use difference of squares on what's inside of my parentheses. Because I have n squared minus 25. I have subtraction, which is what the difference of squares is, and I have 2 perfect squares in there. So the 3, or my GCF, comes down from the outside. Then I'm going to get my 2 sets of parentheses ready to do difference of squares. So I'm looking at the first term, n squared. Well, that would need to be an n and an n. Now I have to look at the 25. Well, 5 times 5 makes 25. And then one of them has to be a plus, one of them has to be a minus. And this would be my answer after I had factored that problem. Let's look at example number 3. Again, I need to try GCF first. So I'm looking at 24 and 18 and seeing if I can do greatest common factor. Well, I can. Both numbers can be divided by, sorry team, there is a typo in this example. We're going to go ahead and change our problem so that it's going to work. This is not going to be 24x to the fourth. It's just going to be 2x to the fourth minus 18. So again, now if I'm going back and I'm trying to think about my greatest common factor, between the 2 and the negative 18, it would be 2. So then I would be left with x to the fourth minus 9. Now I'm going to see if I can go one step further. My GCF from the outside is going to come down. And because both terms inside the parentheses are perfect squares, and there's a subtraction sign, I know that I can do difference of squares. So I'm going to get my 2 sets of parentheses ready to go. If I look at the first term, x to the fourth, well, that would need to be x squared and x squared. Then if I look at the second term, the square root of 9 would be 3, because 3 times 3 makes 9. And then remember, one needs to be a plus and one needs to be a minus. So this would be my final answer to number 3. Looking at problem number 4. First, I would think about GCF. Well, with 121 and 49, there's no GCF there. They don't have anything in common. Now I have to look if I have a difference of squares. So when I look at the first term, yes, I know 121 is a perfect square. It's in my chart. I also know that 49 is a perfect square. But do I have a subtraction sign? No, so I cannot do this problem because it's addition and you can only do difference of squares if it's subtraction. Now let's look at question number 5. Again, I should check GCF first. 25 and 16, do they have anything in common? No, they don't. So now I see a subtraction sign. So I see a subtraction sign, so I know I can do difference of squares. So I'm going to go ahead and get my parentheses ready. If I look at the first term, 25, well, the square root of 25 would be 5. And then p squared, so I would need a p in each spot, so that when they were multiplied, it would make p squared. Now, if I look at the second term, I have 16. What's the square root of 16? Well, that's 4. And then it has a q squared, so each of those 4s would also need a q. And then remember, one is going to be plus and one is going to be minus. Our last example, number 6. First, I need to check for GCF. So I'm looking at 54 and at 6 to see if they have anything in common. Well, they both can be divided by 6, so I'm putting the 6 in the front. Then 54 divided by 6 gives me 9, u to the power 6. 6 divided by 6 would be 1. Now I have to see if I can go one step further. So I'm going to bring my GCF straight down. When I look at my two terms, are they both perfect squares? Yes. Is there a subtraction sign? Yep. So I'm going to get my parentheses ready. Looking at the first term, I have 9u to the power 6. Well, the square root of 9 is 3 and 3. And then to get u to the power 6, I would have to have u to the power 3 on the inside. Then looking at the second term, minus 1. The square root of 1 is 1. And now 1 needs to be plus, 1 needs to be minus, and this would be my final answer.